For those of you who are watching, I'm just waiting on questions. No one's sent any in yet, so I have nothing to do. Okay, so we got our first question. So I'm going to be in section 4.5 and I'm going to be answering question number 6. Trying to get there, so give me just a second. Okay, so we're on section 4.5, question number 6. And the exact question that was asked about was, we have 5 to the x minus 1 equals 3 to the 2x power. And we're supposed to solve that for x. So, and they did ask for us to round to the nearest thousandth. Now, there's a couple different ways you can do this, but the easiest way to do this is to rewrite this as a log problem. So if I were to rewrite this as a log problem, it would be the log base 5 of 3 to the 2x equals x minus 1. So I just started off rewriting this in log format. So this is where my base of 5 came from. So the log base 5 of 3 to the 2x is going to equal the x minus 1 from right here. And we need to now work this out. But before we can work this out, there was a problem because I have an exponent up here. So I need to move my exponents down to become my coefficient. So 2x and then times the log base 5 of 3 equals x minus 1. Now, I still have this weird thing with the log base 5 of 3, but what you've got to remember is that log base 5 of 3 is an actual number. Let me add a different color green in here because this green is not the best green in the world to see. Let's see, there we go, there's a good green. So, this log base 5 of 3, this is an actual number. We can put that in our calculator and get some things. So that's what I'm going to do, is I'm going to put log base 5 of 3 in. By the way, Desmos has a new calculator. It's a scientific calculator, and it will do a lot of your calculations for you. So it's really good. So you should definitely look into that. So, okay, the log base 5 of 3. Is 0.6826. Let me make sure I did that right. Hold on, just double checking my math here. Yeah. So really my problem is now 2x times 0.6826 equals x minus 1. And if this was a whole number, if this was right here, if this was 6, then all I would do is multiply 2 times that number. And that's exactly what I'm going to do now, is I'm going to multiply this 2 times my 0.6826. And I get 1.3652 x equals x minus 1. And now I'm solving for x like I would solve anything else for x. So I'm going to minus x from both sides. Remember, that's a 1x. So if I have 1.3652 and I'm subtracting 1x from that, that would be 0.3652 x equals negative 1. And then to get x completely alone, I'm going to divide both sides by 0.3652. And we end up with, oops, let's group these together really quickly so I can move the whole thing. We end up with, so I'm trying to get this typed in now. Oops. If I was smart, I would have brought one of my yellow calculators home with me, but I didn't think about that. So, negative 1 divided by 0.3652 is going to give me x equals negative 2.7382. And it did ask us to round to the nearest thousandth, so that just means it wants negative 2.738. So that would be my answer. Now, the only other thing we need to do is we need to verify that that is correct, that it's not extraneous, and we do that by going back to the original problem and plugging it back in, which that doesn't take long because it would be 5 to the exponent of negative 0.2738 minus 1 equals 3 to the 2 times negative 2.738. And we would just plug the left side in. Sorry, let's try that again. We would plug the left side in here, and then we'd plug the right side in, and they should give us the exact same answer, which they will, because I know for a fact that is the correct answer. But that is how you would work through that problem. All right, I've got another question. Don't know what section this came from. I'm guessing it's probably somewhere in 4.3. I have a problem of, someone just sent me the picture, 1/5 times the log base b of x to the 4th y to the 7th minus 5/7 log base b x to the 6th y. And we're supposed to write this as a single logarithm. Again, I'm guessing this is from somewhere in 4.3. Because that's where we talked about logs and combining them and stuff. So if we're supposed to write this as a single log, what you need to remember is that the minus sign here is going to turn this problem into a division problem. So when I go to write this as one log, I'm going to have the log base b, and there's going to be a numerator and there's going to be a denominator. And we should figure out what goes in what. So in front of this right here, the 1/5, this is a positive 1/5, which means that all of this is going to end up in the numerator. I got to do a little bit of manipulation with that first, because I do have this coefficient of 1/5, and we don't like coefficients. Coefficients become my exponents. So really this is going to go up here to be an exponent of 1/5. And an exponent of 1/5 is technically a 5th root. So this would be a 5th root of x to the 4th, y to the 7th. So that's done. And then let's talk about the next part of this. So this next part, as we said earlier, was a minus there. So I'm going to move, again, this 5/7 up here is going to become my exponent of 5/7. And I can, I'm going to rewrite it and then I'll do the manipulation with that. X to the 6th, then y to the 5/7 power. So a couple things that are going to happen here. The first thing is that I need to fix this denominator because it's awful, by the way. So that's what I'm about to do. So we have the log base b, the numerator's good, 5th root of x to the 4th, y to the 7th. Denominator not so good because of a couple things. So number one, if I have this 7 in the fraction, in the denominator of the fraction, that's my root. So my denominator is going to have the 7th root of, and then I have still x to the 6th y, and then all of that to the 5th power. And when I have stuff raised to exponents, to the 5th power, I need to multiply that exponent in. So 5 times 6 is going to give me x to the 30th. And this is y to the 1st here. So 5 times 1 is y to the 5th. And, okay, I did get clarification. This is from section 4.3. And this is question number 29. So I'm going to pull that up. I just want to make sure that I don't know if they want you to leave this as the answer or if they want you to simplify it further, because it can be simplified a little bit more. So I need to look at what they have as the answer. So I'm trying to pull up the question really quickly, but this is the basic idea that if something's positive, it ends up in the numerator. If something is negative, it ends up in the denominator. That your coefficients become your exponents, and thinking about your exponents, if they're fractions, then that's where TIBO comes into play, top in, bottom out. So that's what we did here, was the top number was applied to the inside. The bottom number was the outside. It was the root. Okay. So 4.3, question number 29. All right, I'm getting it pulled up because, again, I want to make sure that I do this in the depth that the problem wants it to be done. Okay, so, looking at this, they've asked for a lot more than this. Okay, not a big deal. So, the way this problem is written, and again, I'm looking at the specific problem here. On my test, this would be an acceptable answer. So, for the test, this is what I am looking for. Okay, but for the homework, which again is question 4.3, question number 29, they want this with fractional exponents, and that's it. So I'm going to go back. I have the problem log base b. I'm going to rewrite all of this. It's the 5th root of x to the 4th, y to the 7th, over the 7th root of x to the 30th, and y to the 5th. So I'm going to work the rest of this out the way that the book is going to want it, the way that my math lab is going to want it. So keep in mind, this is what I would want on the test, but what I'm going to do from here is what they're going to want for my math lab. I'm just going to call that MML. So this is what they're wanting for this question. So remember that my roots are really my denominator, so I'm going to put those underneath here. So the numerator will have the log base b of, this will be x to the 4/5, and then y to the 7/5, divided by, here's my 7, and that 7 is going to go in the denominator there, so it'll be x to the 30/7, and y to the 5/7. And when we are dividing, we subtract our exponents. So we need to do log base b of, I need to subtract 4/5 minus 30/7 and get that in a fraction. So I know the person who asked me this has a calculator at home, so that should be easier for them to do than definitely for me. But if I'm going to do this, I need common denominators, and so I'm working this out right now, by the way. 150/35, so I would end up with negative x to the, let's try that in a different color, x, nope, not what I wanted there either, there we go, x to the negative 122/35, yeah, x to the negative 122/35, and then I'm going to do the same thing with the y's. So I'm going to go through and I'm going to subtract 7/5 minus 5/7. And that is going to give me y to the 24/35. So again, that's the answer that they are looking for. Which I believe the person I'm looking at your exact problem, and I think that's answer choice B. So, but that's the answer that, again, my math lab is looking for. Now, as far as it goes for the test tomorrow, I am looking for this form. I want to see that you can get from having multiple logs into one log by putting it in radical form, just applying those properties there. I'm not looking for all of this work with getting all of the exponents and everything else like this. Okay? All right, so far I've gotten 2 questions and I've answered 2 questions. So I'm just hanging out and waiting for more. And again, they can be questions from the homework. They can be questions from the review. Either one, I'm fine with that. If you're sending me a question from the homework, please just tell me what section number and problem number it is. Okay, I had a request to do problem number 6 from the review. So I'm going to flip back and do that. Okay, so on problem 6, you're supposed to find the inverse of the equation. So to find the inverse, the very first thing we do is we flip x and y because we're basically resolving for y. So again, I'm doing problem number 6 here. So I'm going to rewrite this as x equals the square root of 3y squared plus 2. So I'm finding the inverse, which means I'm flipping x and y and then resolving this whole thing for y. So I need to solve for y. That means I need to get rid of the square root because I can't do anything else yet. So I'm going to square both sides. And I ended up with x squared equals 3y squared plus 2. Because remember, a square and a square root cancel each other out. So this square and then this square root symbol here, they're going to cancel each other out. So we're just left with 3y squared plus 2. And then again, still solving for y. So things I'm going to need to get rid of. I'm going to need to get rid of the 3. I'm going to need to get rid of the square, and I'm going to need to get rid of the 2. But the first one I get rid of is that plus 2, and I get rid of that by minusing 2. So I have x squared minus 2 equals 3y squared. Still need to get rid of the 3 and the square. If you're solving and you're kind of not sure what method to go in, remember PEMDAS? Which I know you all remember PEMDAS. Like that's not, that was kind of a duh question. You all remember that. With solving, you work your way up. So you take care of your addition and subtraction first, then you take care of your multiplication, division, then you take care of your exponents. So that just kind of helps you figure out where you're going with all that. So I need to divide next. So I'm going to divide both sides by 3. And I get x squared minus 2 divided by 3 equals y squared. Now I can get rid of that square. And to get rid of this square, I'm going to take the square root of both sides. So I end up with the square root of x squared minus 2 divided by 3 equals y. And there's some questions from some people I was talking to earlier this week, and they were asking, you know, and it was a very valid question, does this square root symbol here and then this square right here, do they cancel each other out? And the answer to that is no. And the reason is because it's not just x squared, it's x squared minus 2. So if I had just the square root of x squared, then yes, the square root and the square would cancel each other out, but I don't. I have the square root of x squared minus 2, and then all of that, in fact, also divided by 3, so it's not going to cancel each other out. So this would be my equation for my inverse. The square root of x squared minus 2 divided by 3. Okay, and another question from the review. Question number 47. All right, so question number 47, we're supposed to solve each equation. So we have e to the 6x power minus e to the x equals e to the 21st. I'm going to write that because that looks really blurry. It says e to the 6x times e to the x equals e to the 21st power. So keep in mind your rules of exponents, that when you are multiplying two problems or two things that have the same base, that's important is that they have the same base, so both of these have a base of e, then that means I can take my exponents and I can add them. So this was really e to the 7x equals e to the 21st power. And you could use your rules of logs at this point, but it's a lot easier than that because it's really just kind of common sense that if I have e to some power equals e to some power, then those some powers must be equivalent. So 7x has to equal 21, and then to get x by itself, divide both sides by 7, and I get x equals 3. So 3 would be my answer to this question. Sometimes you're going to get really ugly answers to these problems, and sometimes you're going to get really pretty answers, like that one, which was x equals 3. So, good question, good question. Okay, next question. Question 91 from the review. This one's a fun one. It's something, at least. It's pretty rough. Okay, so I have negative 2/3, question 91 from the review. Negative 2/3 log base 5 of 5m squared plus 1/2 log base 5 of 25m squared. And just going back and looking at my instructions, it said write this as a single logarithm. So that means I'm going to be putting these together, which means I'm going to have the log base 5 of something. And keep in mind that whatever the sign is, that tells you if that part's going to go in the numerator or the denominator. So if it's negative, that means I'm going to put that in the denominator. So all of this eventually, I'm going to do some manipulation to it in a second, is going to go down here in the denominator. And then the other side is positive, so that means that this part is going to end up in the numerator. Again, I'm going to need to do some manipulation there. So we're going to go back and we're going to look at that. But at least we kind of know where everything's going to go based on our signs. So now that we know that because this was negative, it's going to go in the bottom, let's fix this a little bit and do some math here. So keep in mind that my exponents become my coefficients, become exponents. So it's going to end up being 5m squared to the 2/3 power. Now, I know that I did not bring that negative sign with it. And I did that on purpose. Because that negative sign, all it's telling me is that all that when I write it in a second is going to be in the denominator. So I'm going to leave it alone for now. Because I already know what to do with it. So all I'm doing is just looking then at what happens when I apply this 2/3 here. So remember, when I have exponents on the outside, I need to distribute them in. I need to multiply them times all the exponents on the inside. Well, there's a 1 here with that 5. So that becomes 5 to the 2/3 power. And then m squared to the 2/3 power is m to the 4/3. So, and remember too that, let's see, actually let me zoom back in a little bit and let's manipulate this even more, that when I have a denominator, TBO, top in, bottom out, that this bottom number is going to be my root. So this is the cube root of 5 squared, which is 25, m to the 4th. So that is what is going to go in the denominator of our problem, is the cube root of 25 m to the 4th. So that's the bottom, and now let's look at the numerator. So the numerator is going to come from this part, and again, it comes from the second part of this because the second part was positive. So because it had a plus sign here, then I know all this is, when I manipulate, it's going to go in the numerator. So same rules apply, that my coefficients become my exponents. Biggest mistake I see at this point is people only apply the 1/2 to the m squared here and not to the whole thing. So keep in mind it does go to both parts of it. So I have 25m squared to the 1/2. And remember, there's a 1 here. That's important. So I'm going to distribute this exponent in. So this becomes 25 to the 1/2. And that becomes m to the 1st. Well, because 2 times 1/2 is 1. So the only thing now with the denominator is this 25 to the 1/2 power. Remember, that becomes the square root of 25. And the square root of 25 is just 5. And so in the numerator, all that I am left with is 5m, nothing else. So my numerator would just be 5m. Now on the test, I would totally 100% accept this as an answer, because again, I'm looking to see that you can get to this point. If this is a question on my math lab, they'd probably want you to do a little bit more with it, because you could even go a step further and remember that this here, m to the 4th, means I have 4 m's on the inside, and I'm looking for groups of 3. So then there would be one group of 3. So I could say this is the log base 5 of 5m divided by m times the cube root of 25m. So again, that happened because m to the 4th meant that there was 4 m's on the inside. if I have one group of 3, then there's going to be one on the outside, and then I had this one left over, so it's going to stay on the inside. The only thing that helps me in this case is now I can cancel out these m's here, so then my problem looks a little bit better, but so I end up with the log base 5 of 5 over the cube root of 25m. But again, as far as your test is going for tomorrow, I am 100% confident with, or comfortable with this being your answer. Sorry, that should have been there. 100% confident with this being your answer. So don't stress about having to do all this, because even technically this could be rationalized and then we just have to go through all this stuff. So just focus on, like I said, just focus on this part right here, because this is what I'm concerned about, is can you write it all as one log? Okay, I had a request for question number 92 on the review as well. So very similar problem, negative 3/4 log base 3 of 16p to the 4th minus 2/3 log base 3 of 8p cubed. So I'm trying to combine this to make this into one log. So now it's going to be the log base 3. And then I have to look at my sign. So this minus tells me that that part is going to go in the denominator. So I'm going to have part of this in the denominator. And then looking at the second part, it's also a minus. That means that's also going to go in the denominator. So I'm not really left with anything in my numerator. And whenever that happens, I have nothing left in my numerator. I can put a 1 up there as a placeholder just to fill in that spot. So that is acceptable. So now we just need to do the manipulation and do the math. So I'm going to zoom in. I'm going to focus on each part of this. So remember this 3/4, moving it up here, it becomes my exponent of that entire thing of 16p to the 4th. So I need to apply that, and I need to multiply that out. So there's an exponent of 1, so 16 to the 3/4 power. And then 3/4 times 4 would just be p to the 3rd. So 16 to the 3/4, well, that's the 4th root of 16 cubed. And the 4th root of 16 is actually 2, because 2 times 2 times 2 times 2 times 2, so 4 2s. It's going to multiply to give me 16. So really this is 2 cubed, and 2 cubed is really 8. So that means that all of this that I just like messed with, this 3/4, 16p to the 4th, all of that becomes 8p cubed. So that's going to go in the denominator of our problem. So that's the first part, is 8p cubed. And then I have, okay, so now we're going to do the same thing over here on the right side. 8p cubed to the now 2/3 power, because again my coefficient is going to move up here and become my exponent. And just like on the last problem, I didn't bring that negative sign with it, because all that negative sign is telling me is that it's going to go in the denominator of my problem. So I can distribute that exponent in. Well, there's an exponent of 1 here, so that becomes 8 to the 2/3 power. And then p to the 3 times 2/3 is just 2. 8 to the 3/2 power actually is going to work out well, because that becomes the cube root of 8 squared. And the cube root of 8 is 2. And 2 squared is 4. So this becomes 4p squared. So that's the other part of my denominator. So everything now is going to end up in the denominator. So I have 4p squared, and that's going to go on the bottom as well. And down here, all of this has ended up being multiplied. So this actually is going to look a lot better in the end, that I'm going to have the log base 3 of 1 over 32p to the 5th. And I got that just because I went ahead and multiplied 8 times 4, which is where the 32 came from. And then when I multiply, add my exponents, and 3 plus 2 is going to give me that 5. So I end up with my final answer of log base 3 of 1 over 32p to the 5th. Now on this problem, if you had one like this on the test, I would want you to go ahead and work it out, because with all of your numbers and stuff, it worked out to be much better. This one, it didn't really simplify as easily, but here, because like I can actually do 16 to the 3/4 power and get a number, and here I can do 8 to the 2/3 power and get a whole number. We want to go ahead and work those out as much as possible without being like, you know, ridiculous, obviously, and ending up with like, we don't want to try and take the cube root of 25, because the cube root of 25 is, I don't know, it's almost 3. It's probably 2.8 or something like that if I had to guess. But we just want to try and make sure that we're simplifying this as much as possible. So, currently have answered all of the questions that I have gotten at this point. So back to this. And please make sure that when you're sending me questions, that they are questions in regards to the math. Whether that's your review or your homework. Either one is totally fine. And shout out to the 4 people who are currently watching this. It really may only be 3 because I may be one of those 4. I'm not really sure if it's counting me. Okay, so I had a request for question number 26 on the review. Let me find that one. I don't know actually which page that's on. Nope, not there. Okay, I'm not finding a question 26. See if I have answers for it. Okay. Oh, I know where it is. Sorry. Let's try this again. There we go. There's question 26. Okay. So we're supposed to use all properties of logs to expand this problem out. So this means we're just doing the opposite of what we did on question 47 below this, where I'm taking something that's, what we did on the last question, on question 91 and 92. So I'm taking something that's 1 log and I'm writing it as multiple logs. And kind of the easiest way to figure out how many logs I'm going to write this as is I'm looking at the quantity of variables that I have in this problem. So there are 1, 2, 3, 4 variables, which means this is going to be 4 terms. The only exception to that would be if I had a coefficient. So like here, I have 3 variables and a coefficient, so I'm actually going to still have 4 terms there. So I'm just looking at how many variables, how many terms do I have, and then each variable becomes its own log. Each variable becomes its own log. Let's try this again. There we go. So this x squared is going to become the log base 5 of x squared. And then remember that your exponents become your coefficients. So I'm going to go ahead and I'm going to move this 2 down here to the front. So it'll be 2 log base 5 of x. And I'll put in signs in a second. And then y to the 4th here, well, applying that same rule that it's going to be 4 log base 5 of y. And then I have the 5th root of m cubed over p. So remember, my roots become my denominators. So really this becomes m cubed, or sorry, m to the 3/5 power. So that's going to be 3/5 log base 5 of m. And then I have my p here, but it's also inside that root. So that means that my denominator of this fraction, or of this exponent, is going to be a 5. So that's p to the 1/5 power. So I'll have a coefficient. Let's group this to the page so it'll move with it. There we go. So I'll have 1/5 log base 5 of p. And really, and then I got to add in my signs, and the signs literally just depend on whether or not this term was in the numerator or the denominator. If it's in the numerator, it's positive. If it's in the denominator, it's negative. I didn't have a denominator here, so everything ends up being positive. So this would be the final answer to this question. It would be 2 log base 5 of x plus 4 log base 5 of y plus 3/5 log base 5 of m plus 1/5 log base 5 of p. Okay, so at this point I've again answered everything I have, so just waiting on questions. Okay, so question number 60 on the review. Okay, so we have the natural log of e to the natural log of x minus the natural log of x minus 4 equals the natural log of 3. So there's a couple things that apply here in this problem. First of all, let me rewrite this over to the side so that I can work it out. And I will tell you, this problem is way easier than it looks, because it looks pretty rough. I'm not even going to disagree with that. Equals the natural log of 3. Okay. All right. So as always, whoops, let's try that again. As always, whenever I have exponents, they actually can become my coefficients. So I'm going to rewrite this problem as the natural log of x and then times the natural log of e minus the natural log of x minus 4 equals the natural log of 3. So what you need to remember is that what's going to help you on this problem is remembering that the bases are e for every single one of these. And the reason that that helps me is because whenever my base and, oops, didn't mean to do that. Let's try this tool. Whenever my base and what I'm taking the log of are exactly the same, all of this is going to work out to just be 1. So really this problem is just the natural log of x minus the natural log of x minus 4 equals the natural log of 3. And applying my log properties, that if I am subtracting, that I can turn this into one log with division. So this becomes the natural log of x divided by x minus 4. And again, that happened because this was a minus. And then equals the natural log of 3. And if I'm taking the natural log of something and equals the natural log of something, then those somethings must be equivalent. So I can drop the logs, and I get x divided by x minus 4 equals 3. And this is a problem that I can then solve. So to solve this, I need to multiply both sides by x minus 4. And that gives me x equals 3x minus 12, because I just distribute that 3 in there. And I'm still solving for x, like just basic 7th, 8th grade math solving for x. So I have negative 2x equals negative 12. And then divide by negative 2, divide by negative 2, and I get x equals 6. So 6 is the answer that I've come up with. The only thing is I need to make sure that it is not extraneous. So I need to go back and I need to plug it back into my original problem. So to this problem, I have the natural log base e of natural log of 6 minus the natural log of 6 minus 4 equals the natural log of 3. And what you need to do is just plug the left side in and see what it gives you, and plug the right side in and see what it gives you, and they should be equivalent. I'll tell you that they will be, because in this, the only time that you really have issues with this when you find extraneous solutions is when, like, if you do the math, like 6 minus 4, if you were to get something negative, that would be the problem. But 6 minus 4 is positive, and here I don't have to do any math, so this problem is going to work itself out. So the correct answer to this question would be 6, and it would not be extraneous. Okay, I had a request for question number 44 on the review. So we have 5 to the x plus 2 equals 2 to the x minus 1. Okay, let me rewrite that over here to the side. So 5 to the x plus 2 equals 2 to the 2x, well, let's try that again. 2 to the 2x minus 1. And anytime I'm solving an exponential problem and I don't have common bases, I'm going to have to use logs. I'm going to have to rewrite this question as a log. So the way that I would write that would be the log base 5 of 2x minus 1. I'm sorry, let's try that. Of 2 to the 2x minus 1 equals x plus 2. And my exponents become my coefficients. So this would be 2x minus 1 times the log base 5 of 2 equals x plus 5. And remember that log base 5 of 2 is an actual number, that I can put that in the calculator and I can get an answer for that. So if you're using one of my calculators, that'd be Math Alpha Math. I'm using Desmos, so I have to find the log base option there, which exists. So log base 5 of 2 is 0.43067. 0.43067, yeah. So I'm going to rewrite this for what it is, which is 2x minus 1 times, and again, just putting this in the calculator, log base 5 of 2 gives me 0.43068, I guess, if I rounded correctly. That's what it would be. Equals x plus 5. And this problem, I acknowledge, looks horrible because I have this awful number, but imagine what we would do with it if it was just 4 instead of 0.43068. That all this number needs to happen is it's being multiplied by 2x minus 1, which means I need to distribute it in. So I need to multiply it by 2. which is going to give me 0.86136x, because it was 2x times 0.43068. And then I need to multiply it by -1, so minus 0.43068 equals x plus 5. And now it's just a basic solving problem. It looks pretty ugly, like not even going to deny that, but it's not a difficult problem. So I need to get all of my x's onto the same side, and then all of my numbers onto the other side. So this is, remember, minus x is really minus 1x, so 0.86136 minus 1 is negative 0.13864. X equals 5.43068, because when I add 5 and 0.43068, I just get 5.43068. And then to get x completely alone, I would just divide both sides by negative 0.13864. And I would get x equals 5.43068 divided by negative 0.13864. Gives me negative 39.17. So that would be my answer to this question. Let's make sure I got that right. So this was question number 44. Okay, let's flip over to the answer key and make sure that I did that right. I totally did something wrong. Hold on. Oh, I know what I did wrong. Let's try this again. This should have been a 2. I just wrote the problem wrong to begin with. So this should have been 2 right there. And that gives me, there we go, that's much better. X equals negative 17.5323. So that would be my answer to this question. Pretty sure that I've done everything that I've been asked for. So if you send in a question and I didn't do it, please just send it in again. Because I think I've done everything that's come through, but I could have missed something easily. Okay, so I'm going to do a question from the homework because I had a request for one. So I'm doing a question from section 4.3, I'm sorry, 4.1, and then I am working on question number 4. So 4.1, question number 4. Which says that fill in the blank to correctly complete the sentence below. So we have f of x. Okay, and the big thing here is just understanding notation. F of x equals x cubed, then f inverse. So you remember that when you see this notation, f negative 1 of x, that this really means f inverse of x. And if I want to find my inverse, then the first thing I need to do is I need to switch x and y. And then I need to resolve for y. So I don't have x in this problem. I don't have y in this problem explicitly, but remember that f of x is really the same thing as y. So this problem is y equals x cubed, but step number 1 tells me to switch x and y. So x equals y cubed. And then step number 2 tells me to resolve for y. So I'm just trying to get y by itself. Well, the thing that's keeping y from being alone right now is this cubed. So to get rid of it, I would need to do the opposite of cubing, which is to cube root both sides. So this would mean the cube root of x equals y, or, because this was the inverse, it'd really be the cube root of x equals f inverse of x. So that would be the answer that it's looking for to this question. Okay, so same assignment. 4.1, this time I'm doing question number 5. So, if a function f has an inverse, so it gives me some information. It tells me that f of -3 try this again. F, there we go, of -3 equals 6. Then f inverse of 6 equals blank, and you're supposed to figure out what that is. So remember that when you're doing these problems, that the number in the parentheses is x, and then the number that it equals is y. Like f, this is supposed to be f of x, so this number is x and this number is y. And the whole purposes of inverses is that your x's and your y's are flipping. So in your inverse function, which we know this is the inverse function because it says f inverse of x, then these numbers should be in opposite places. So my x should now be 6 because, again, these two are flipping. Like what was my y is going to become my x. So 6 is going to become my x. And then what was my x is going to become my y. So it's going to equal -3. So that would be the answer to that question. I'm going to wait for about 3 more minutes and see if I get any other questions. I hadn't had any in a while, so I think it's probably about time to call it quits. Alright, it's 5:40 and I haven't gotten any questions in probably about 10 minutes or so at this point. So I'm going to go ahead and, oh, it's been way longer than that. Sorry, guys. So I'm going to go ahead and call it quits for the night. So if you need anything, please text me and remind. I'll be checking it periodically. And I'll be at school tomorrow morning at 7:20. So see you guys later.